Welcome, Nick. I was about to get started with nobody here. So I'm glad you're here so that I'm not just doing a lesson by myself. So I'll get started sharing my screen, and I lost you. Okay, well, don't know what I can do. Oh, and let me try to share that again. We're getting a rave. Okay, much better. Okay. I wish that I could get my image on the screen while I'm presenting, but it does not work that way in Collaborate. So this session, I don't know if I should wait to see if he's going to come back. Maybe I should wait. Welcome back. So hopefully you're able to hear me and everything. You're the only one here. So you get to ask as many questions as you want. So I'm going over completing the square. This is, let me actually write this on the screen. So I'm going to just put a little asterisk here. So this is not going to be quizzed on. That's really nice to know. But it is necessary to at least have seen this. Wow, I don't know how to spell necessary. I'll just say important. Important for pre-calculus and calculus. So we're not going to quiz on it here, but at least you'll have it in your notes for when you need it in pre-calc and calculus, because it does show up in pre-calculus when you're dealing with conic sections, which are circles, ellipses, hyperbola. And then in calculus, a lot of times completing the square is a nice little trick to make your integration and derivatives simpler and easier to do. So this is just, I'm doing this video so at least you have it in your notes and you have something that you can refer back to when you are in those classes if you have to go take those classes. So what exactly is completing the square? So completing the square is kind of like a magic trick. So this is something that I didn't learn was possible or something that you could do until I was in my third year of college. And it wasn't my third year of college. It was because it was when I switched and got my second degree. So it would have been my fourth or fifth year of college. It was when I started getting my math degree, and I was taking a class called Real Analysis, which is about the theory behind calculus. And in that class, we do a lot of manipulating of equations, and you are trying to take what you have, which isn't easy to work with, and you are doing things to it to make it easier. And often what that means is you add and subtract something to it. Now, you add and subtract the same number. Adding and subtracting the same number is the same thing as adding 0 because they cancel out. But the ability or the process of adding and subtracting the same thing can allow you to manipulate it differently than what you normally had. And so it's like a little magic trick to add and subtract. To basically, you're adding 0 because you're adding and subtracting the same number, but it allows you to rearrange the equation differently. That makes it easier to work with. The AC method is actually similar to this, because the AC method of factoring, you're taking that middle term and you're splitting it apart into 4 terms. Or 2 terms. You haven't actually changed anything about the equation, but you've split it up in such a way that it makes it easier to work with. So completing the square is similar to that, where you do something that makes no sense. Why would you add and subtract the same thing? You know, why would you add 2 and then subtract 2? That's stupid, but it actually is a useful trick. So what we do is that we're going to have something that's not a perfect square trinomial. This is a perfect square trinomial right here. It's one of those special things that we learned about. So we are taking something that's not a perfect square trinomial. We're going to make it a perfect square trinomial by adding, subtracting, and we're going to do some other manipulation, and we're going to do it in a certain way that will allow us to factor that perfect square trinomial. So you'll use completing the square when you have something that does not factor. You can always complete the square. So the quadratic formula is one thing that we use if we can't factor. Completing the square is another method that you can use when you can't factor. And so we turn the equation into something that we can factor, and then you're going to end up with something squared, and you use the square root property. This will make a lot more sense once you actually see it worked out. But I wanted to make sure that, you know, you have all the steps there, so that way you know you have a recipe card to follow. Now, just as an FYI, if you're wondering how we got the quadratic formula, it's by doing completing the square. So the quadratic formula, completing the square is the process. The quadratic formula is the final product of completing the square, if you want to think about it that way. So step 1 is, if you have a constant in front of the squared term, divide it out, and you have to divide everything by that. Most of the time this comes out with fractions when you're completing the square. So having a calculator that does fractions is key, very important. Step 2, you rewrite the equation so that your constant term is alone on the side of the inequality. So instead of making it equal to 0, you want to have it equal to a number. So we want to have stuff equal to a number. So just junk over here equal to a number. So it's sort of undoing everything you learn about quadratic equations to solve as you have it equal to 0. In order to complete the square, you don't want it equal to 0. So it's kind of weird. Then step 3, you are taking the middle term, what would have been the middle term that you started with. You take half of that number, then you square that. And then that's the number you add to both sides of the equation. Now, we are allowed to add things to both sides of the equation. It doesn't change anything. I mean, that's how we solve equations. So we're going to be doing that. We're going to be adding and subtracting that, or adding that on both sides of the equation. This is equivalent to adding and subtracting it on the same side and then adding one of those to the other side. So that's why I was talking about the trick where you add and subtract the same thing. You're not changing it. That's basically what we're doing here. We're just going to skip a step and add it to both sides. So step 4, you want to factor your resulting trinomial as a perfect square. So just as a reminder, if you have a perfect square trinomial, I pointed that on the last slide, this is how it factors. So we have something, we have no number in front of the x squared. And what's special about C is that it's a number squared. And then the middle is twice that number. So that's the specific perfect square we're going to be dealing with. And then that factors, so it's x plus that number squared. So we're going to get on the left side something that we can factor in this form. So we're going to factor it. And then on the right side, you're just adding whatever numbers you have together. You're just combining those like terms. And then step 5 is you're using the square root property to actually go ahead and solve. So we haven't done any solving yet. Step 5 is where you start solving. Everything before that is just to manipulate it into the form we want. And just as a reminder, the square root property, that's if you have something squared equals a number, then you take the square root to both sides, and you'll end up with plus or minus the square root of something. So let's see this in action. And remember, you're not going to be quizzed on this. This is just for reference for those of you that have to go on to pre-calculus, calculus, that sort of stuff. So I'm going to start with one where we don't have a coefficient in front of the x squared. So we've got x squared minus 2x minus 3 equals 0. This is something we can solve by factoring, but we're going to use completing the square just to practice this. And then if you want, you can solve by factoring to verify the answer. So your first step would be, if there's a number in front of the x squared, you remove it. So, but we don't have anything like that. So we want to move the constant to the right side. That is going to be our first step. Move the constant to the right side. So we are going to be adding 3 to both sides. And this gives us x squared minus 2x equals 3. Now we're not factoring the left side. What we're going to do is complete the square. That's what this whole this thing that we're going to be doing is called completing the square. So that's what this step is called. So you take the middle term, which is your b, you divide it by 2, and then you square that answer. So I'm going to do this in, let's just do blue. Our middle term is -2. I'm going to divide that by 2, and then I square it. So -2 divided by 2 is -1. So we have -1 squared, which gives us a +1. And we're going to add this to both sides of the equation. So I'm going to be adding 1 to the left and the right. So that gives me x squared minus 2x plus 1 equals, and then 3 plus 1 is 4. So we just completed the square, because now what we have on the left is something that we can factor. That would factor to x minus 1 times x minus 1, which is just x minus 1 squared. So step 3 is to factor the left. So that will give us x minus 1 squared equal to 4. And the key here is what I had in parentheses before I squared. So this number right here, before we squared, that is the same number that goes inside parentheses. So if you recognize that, you don't even really need to think about it and try to factor, because you just automatically know what number that's going to be when you factor, because you found that number in the process to get this square. So I'm running out of room, so I'm just adding some blank slides just to make sure I have enough space. Okay, so we've done all of that. Step 4 is to solve using the square root property. So that's where we're actually solving. Oh, I wrote square root problem, square root property. So I'm going to go on to my next slide, and I'm going to rewrite what we have. The x squared the x minus 1 squared equals 4. So we have x minus 1 squared equals 4. So to solve by the square root property, you take the square root of both sides. So I'm writing that in a different color to demonstrate that. It cancels out your square, so you're just left with x minus 1 on the left. And then we always get a plus or minus when you take the square root. And the square root of 4 is 2. So we're going to get plus or minus 2. Now when you end up with whole numbers like this, we need to write two separate equations because of the plus or minus before we can continue solving. So we're going to write one where we have the positive 2. So we're going to have x minus 1 equals a positive 2. And then another one where you have x minus 1 equals a negative 2. And then you solve both of those by adding 1 to both sides. So I usually just do it on both equations at the same time. And we get x equals 3 and x equals negative 1. And so we write our solution set, because this is usually how Alex wants you to write it, is you kind of put it in curly braces. And curly braces will already be in Alex. You just basically plug in the numbers and you separate them by commas. So that's the completing the square process. Let's do another one so you can see that process again. Here we've got a number in front of the x squared part. So this is just going to be one extra step. And it's going to come up with fractions. So you want to have a calculator that does fractions. And I swear by this website, Desmos. If you go to Math Tools and then the Scientific Calculator, it can do fractions. There's a fraction button. So I'm not going to show the work for adding fractions, getting a common denominator, any of that kind of stuff. We're going to use the calculator for all of our fractions. There's no reason that we need to do the fractions by hand because we want to focus on the algebra, not the arithmetic. So you're going to use a calculator for anything that deals with fractions. And so you just need to make sure that you have a calculator that can do that. So our first step is to divide everything by the number in front of the x squared, or by a, because if we look at this, this is our quadratic. It's in the form ax squared plus bx, and it's not actually plus c. We've got c on the other side, but we've still got a in front of that x squared part. So divide everything by a is going to be the first step. So that means that I'm dividing by 4. And we're going to get a fraction because we're going to get it equal to 1/4. But that's okay because our calculators can do fractions. So we get x squared. And then the 4 divided by 4 is 1. So that's going to be a minus x equals 1/4. Now, step 2 would be to make sure that it's not equal to 0. You want to make sure that any whole numbers, or well, not whole numbers, but any numbers without any variables are on the right side. And we already have that here, so we can skip that second step and we can move on to where we are going to complete the square. So that will be complete the square. And so again, that formula is you're taking half of b and then squaring it. So b is the number that's in front of the x, which is going to be a negative 1 here. If it was just negative x, we're going to see it as a negative 1. So we're going to have negative 1 over 2 squared. So whenever you square a negative, you get a positive, and this is going to give us a positive 1/4. Make sure when you're doing anything with exponents, if you're squaring anything negative with exponents, you have to have parentheses around the negative number. Otherwise, your calculator is going to assume the negative is not part of the exponent, but it is. So we took half of the middle term and then we squared it, which gives us 1/4. and then you add 1/4 to both sides. So I'm just going to write that in, 1/4 plus 1/4 here. That will give us x squared minus 1x plus 1/4 equals, and then 1/4 plus 1/4 is 2/4, which is 1/2. So we've got it equaling 1/2. Step 3 is to factor the left side. And so now you're probably thinking, oh crap, we've got a fraction here on the left side. How do I factor it? Well, remember this trick that whatever was inside before we squared, that's what you're going to get when you factor, since this is a perfect square trinomial. So this is going to factor to parenthesis x minus, and it's minus because we've got because it's a negative 1/2, so it's just literally whatever that number is. So we're going to have x minus 1/2 because it's a negative 1/2 squared equals 1/2. So you don't even have to do any thinking when you have something with fractions here. It's already, you know, when you're doing the complete the square process, it's basically giving you that number so that you already have that number that is going to be part of the factoring, and you don't need to actually think about it. So you don't have to really think about, crap, how do I factor something with fractions? So once you've got that factor, then step 4 is to solve using the square root property. And so that's where we're going to take the square root on both sides. So I'm going to move to my next slide so I can continue. So we have x minus 1/2 squared equals 1/2. And to solve, we take the square root of both sides. And this is going to be kind of gross with the fractions, but we can do it. So it cancels out the squared part, and we just have x minus 1/2. When you have the square root, you're going to have a plus or minus. And then when you're taking the square root of a fraction, we might want to write this work off to the side. So we have the square root of 1/2, or 1/2. So we have to go back to what we learned about radicals, that if you have a fraction, you can split up your square root. So this could be the square root of 1 over the square root of 2. So the square root of 1 is 1, so this is 1 over the square root of 2. Now we do not want to have square roots in the denominator of a fraction, so we need to rationalize the denominator. And what that means is you multiply the top and the bottom by whatever your denominator is. So we're going to be multiplying the top and the bottom by the square root of 2. And so this ends up with the square root of 2 on top, and then your square roots cancel. A square root of 2 times the square root of 2 is square root of 4, and the square root of 4 is equal to 2. So this is going to become plus or minus square root of 2 over 2. I like to put that work off to the side because otherwise it can get really confusing when you're trying to do that within a fraction. So I'll put it off to the side, get my final answer, and then put it in with my next line so that it doesn't get too messy. And you can just make a note of yourself what you're doing there with those square roots and everything. Now, unlike when we had whole numbers, so if I go back 2 slides, when we were solving this one by taking the square root, once we had whole numbers, we need to create 2 separate equations. When you don't have whole numbers, like if you have an imaginary number or if you have square roots, you don't really need to do that. So what you can do here is just literally add 1/2 to both sides. And so the way that we usually write this is we put the non-messy thing first. So that means the thing that does not have a square root, or the thing that does not have the I. So we put that first, so that would be 1/2. And then we have plus or minus the square root of 2 over 2. So when you're answering something like this in ALEKS, if ALEKS gives you a plus or minus button, then you can use that button to enter this in. Sometimes they give it to you. If they don't, then you just need to separate this out as 1/2 plus the square root of 2 over 2, and then 1/2 minus the square root of 2 over 2. So it depends on what they give you, on whether you can write it as the condensed form with the plus and minus sign, or whether you have to write it as two separate things separated by a comma. Okay, no questions. So I've got one more example, which is perfect. So that means David gets to see a full example. And of course, these are recorded, so you can go back, review what you missed at the very beginning when I send it out tomorrow. This is tricky, but I wanted to do this one because this is one where usually people mess up, because you see something that's already factored and you're like, oh, I can just say 2w plus 5 equals 2, w minus 1 equals 2, because the equation is equal to 2. But it doesn't work that way. It only works if it's equal to 0. If it's equal to 2, it doesn't work that way. So what we have to do is actually multiply everything out on the left and then start from there, because it's not in the right form. We basically always have to start with some variation of standard form where you have ax squared plus bx plus c. So first thing we need to do is FOIL. So that's going to be the 2w times w, which gives us 2w squared. Then 2w minus times minus 1, so that's going to be negative 2w. 5 times w, so that's plus 5w. And then 5 times negative 1, which is minus 5. And then all this is equal to negative 2. And then I'm going to combine my like terms. So I have 2w squared. Negative 2 plus 5 is a positive 3. So it's plus 3w minus 5 equals 2. Now we are in the right form that we can use completing the square. And completing the square, it doesn't matter if it's equal to 0. It just has to be multiplied out on the left side. So what I like to do is actually add the 5 to both sides first before dividing by 2, just so that I'm adding that stuff first before I'm creating fractions. Because I'm looking at this, you divide by the number in front of the w squared, so we're going to have a 3 over 2. We're going to get fractions. So I just want to do the stuff that I can do with whole numbers first, just to avoid doing math for fractions. So in previous ones, we added that thing later. We did it second. The order in these two steps doesn't really matter. So we're going to add the constant to the right. Or move the constant to the right, I should say, because sometimes you subtract it from both sides. So I'm going to be adding 5 to both sides. So I got 2w squared plus 3w equals 7. Now I need to have the w squared have no number in front, basically be a 1, not a 2. So I have to divide everything by 2, which is a in standard form. So step 3 would be to divide everything by a. So that 2 over 2 of those cancels. We're going to get 3 halves and 7 halves here. W squared plus 3 halves W equals 7 over 2. So yes, it's messy, but use your calculator to do the fractions. Don't make them decimals because sometimes that introduces rounding and then could cause you to get incorrect answers and ALEKS. So you don't want to make them decimal. You want to leave them as a fraction, but just make sure you have a calculator that can do fractions. So the next step is to do the completing the square step, basically. So I'm going to move on and I'm going to copy down what we have here. We have W squared plus 3 halves W equals 7 halves. So just copying that down. So step 4, complete the square. And so that is, you're taking B over 2 and squaring it. So B is the number in the middle that of what it would have, what would have been B when you have A squared plus B squared, or AX squared plus BX plus C. That's the one in front of the sickle, the variable without the exponent. So we've got 3 halves, but we need to divide that by 2. So it's going to look messy, and then square it. Well, the nice thing is if you're using your calculator to do fractions, you can do this on your calculator, and you're going to get 3/4 square, which then when you square that is going to give you 9/16. So use that calculator to do this math. Don't mess around with the fractions. You're going to it's really easy to make mistakes. Use the calculator to do the math. So we're going to add 9/16 to both sides. So sometimes what I do is when I write my stuff, I actually leave a space for that to write that in. So you can see in this case, when I rewrote it, I left that space in, so I had room to write plus 9/16, and I added that to both sides. So we're going to simplify this. So we've got W squared plus 3 halves W plus 9/16 equals, and then on the right we have 7 halves plus 9/16. So use your calculator. I'm going to just bring up the scientific calculator in decimals. So all the fraction stuff I've been doing so far mentally, but this is what I'm not going to do mentally. So I'm going to hit fraction, 7/2 plus fraction 9/16. And then it gives me this decimal. I just hit the button to convert to a fraction. So we're going to get 65/16. So that's what I'm going to write on the right side here is 65/16. So step 5 is to factor the left side. And the nice thing is that whatever is going to be in our parentheses when we factor this, we already found that number. It's going to be 3/4 right here. So we're going to get W plus 3/4 because that's positive. And then that whole thing is squared, and it's going to be equal to 65/16. So I don't really have to think about how am I factoring this thing with really nasty fractions. The whole reason we're doing what we're doing is so that it factors and it makes it easy to factor because we already found what that number was. So I have W plus 3/4, and then that's squared, then equals 65/16. So step 6 is to solve by taking square roots. So we're going to take the square root of both sides. And so we get w plus 3/4 equals, and then I'm going to get this square root of 65 over 16 thing. We get a plus or minus, and I'm going to do my work on the side to simplify that. So the square root of 65 over 16. We're simplifying this radical, so you're splitting it up. So we've got the square root of 65 over the square root of 16. So square root of 16 is 4, but we need to simplify 65. And I want to see, can I split that up into something that I can then, take the square root of? Does that simplify? So what I do is I just bring out my calculator and I start dividing it by perfect squares. So 65 divided by 4. I get a fraction, so I move up to the next one. 65 divided by 9, fraction, or decimal. 65 divided by 16, decimal. 65 divided by next one's 25, decimal. The next perfect square, that's 5 squared. 6 squared is 64. I mean, 65 is not going to be divided by 64. So I just keep going until I have satisfied that I'm not going to be able to split this up with, so I can't take a square root. There's going to be no square root that I can take here because I tried my perfect squares. So we're going to leave this as the square root of 65. It doesn't actually simplify. So I'm going to write that down here. We've got the square root of 65 over 4. So it's okay to have a square root on the top. We just can't have a square root on the bottom. And then because we've got square roots going on here, we don't have to write it as two separate equations. So I can just subtract 3/4 from both sides. And so I'm kind of running out of room here. I don't want to get a new slide just for this. So our answer is going to be W. We put the negative 3/4 first because that doesn't have the square root. We always put the plus or minus thing in the middle. And then we have the square root of 65 over 4. So that would be your answer. Or if you were putting this in Alex and I wanted it separated by commas, you just write one of them with the plus, comma, and then the second one with the negative. And so that's your final answer. Are there any questions on this example? Okay, I'm not seeing anything in the chat, not hearing anything. So we did have some people join during this third example. This was my last example. So if you joined in the middle of that, it probably makes absolutely no sense to you. So I'm going to just go back to the beginning just as an FYI. Completing the square is not going to be on your quiz because it is a rather long process. So you're not going to be quizzed on it. But it is important if you have to go on to take pre-calculus and calculus, which is why I'm covering it. So those are people who are going into computer science or engineering. I think those are the IT, cybersecurity, anything involving computers or electricity stuff. You're going to have to take those classes. And so you're going to need to know how to do this because it will kind of pop up in those classes. So that's why I'm covering it, but you are not going to be quizzed on it. But you want to make sure you have this in your notes so that way when you move on, you have it so you can reference it. And just in general, because I've emailed a few people this week regarding notes and quiz work and stuff like that, don't throw anything away. When you're in college, And actually, I haven't even thrown away some of my stuff when I was in college because it still is handy in my job. Um, so when you're in college, do not throw anything away during a class. So if you do something, get homework while you're, in a class, have work from a quiz, don't throw it out while the course is just going on or still going on, because, and this is true for anything, not just math. Your midterms are usually cumulative, so they involve information from half the class, and so you might need to refer back to and study previous quizzes because usually those same questions show up on the midterm. And then the final exam is usually cumulative, and so covers the whole class or the second half of the class. And again, usually questions from the quiz or the homework shows up on the final exam. So don't throw any of that stuff out because you can use that to study. Second reason you don't want to throw it out, let's say it's the end of the term, you're done with the class, and you're like, let me throw this out. Well, you're taking the course for a reason. You're going to need this information in another class. So even though the class may be done, you may still need this information. And let's say there was a question on a quiz on something, and you're like, I knew this was on a quiz. Let me see how I did it. If you throw away your quiz work, you can't look back to see how you did it. So I recommend don't throw away anything until you have your degree in hand. And even then, often on the job, you'll have to refer back to some of these things. So my dad, he's a mechanical engineer, and he kept all of his engineering books, and he referred back to them while he was working, because you don't remember everything you learned. You're not going to retain it all. It's not going to be in your head. You're going to forget things. That's normal. But if you keep your books, if you keep your notes, you have it there so that you can pull it out when you need it when you're on the job. So this is a general tip for everybody, no matter what degree you're in, no matter what class you're in, don't throw away anything. Once you've been on the job long enough, then you can kind of decide whether you need to keep something or not. But don't throw away anything while you're getting your degree because it's going to come in handy and you'll regret it. So just FYI about that. I think for some people, they never realize that, oh, I might need that. Nobody ever tells you that, like, oh, you should really keep this. So I wanted to make sure to get that out there. And so again, that's why I'm doing completing the square, because while you're not going to be quizzed on in this class, you do need it in another class, so you'll have it for your notes.